In order for regression to work, we need to convert categorical variables into dummy variables. A dummy variable is basically a categorical variable with two levels: yes, no, on, off, male, female, and usually coded as 0 or 1. If a categorical variable has L different values, then we would create L-1 dummy variables. Another approach is the one-hot encoding, which give L variables, each for one of the values. Let's try the COS93 dataset. First, we will a linear regression model for one variable, which is horsepower. CTMPG is the dependent variable. And later on, we add type of cars. Type is a categorical variable, so we will see how this variable is converted into dummy variables. On the left side, the regression model has only one independent variable, which is horsepower. On the right side, we add another variable, namely type. Looking at the coefficients section, we can see each categorical value is now one of the dummy variables. The name of the dummy variables is based on the name of the categorical variable and the values. So for type, we have type large, type midsize, type small, type sporty, and type van. We always omit one of the values. In this case, compact is not one of the variables. The coefficient for a dummy variable indicates a change in the target variable. If the instance change is from the value omitted, in this case compact, to the value indicated in the dummy variable. As an example, the coefficient of van is estimated as minus 4.96. This means that a van will get 4.96 less MPG than a compact car, if all else are equal. When building a linear regression model, there are 5 assumptions to check. The first assumption is that the relationship between the X predictors and Y are linear. If they are not linear, meaning a rejection of the null hypothesis, we would probably need to add an additional transformed X term to the model. For example, a quadratic term. The next to check is the assumption of normality. If the distribution is skewed positively or negatively, you would reject the null hypothesis and you would need to transform your data. Also, if the distribution is cathodic, highly peaked or very shallowly peaked, you would reject the null hypothesis and you need to transform the data. The next to check is to see if your dependent variable is continuous or categorical. Rejection of the null hypothesis means that you will need another form of the generalized linear model, such as logistic or binomial regression. And finally, you need to check the variance of the model residuals. If the residuals are constant across the range of H, rejection of the null hypothesis means that the residuals are heteroscedastic, meaning non-constant across the range of x. As a result, the model is better or worse at predicting for certain ranges of x. In R, we can use the GVLMA given a model, the GVLMA function given a model, for checking all 5 assumptions.